Hello, everybody. It's me again, Rich Andre, and today we're going to be talking about limits, limit theorems. Okay, so this will encompass all of the theorems on limits. Okay, and before we do that, let's first start off with a little bit of sort of description on the limit theorems. So let's start with the constant law. First law is the constant law. Constant law. Okay, so just here, limit of a x is limit of c as x approaches a is equal to c. So let's get an example of this so we can visualize what happens here. Okay, so let's start with the constant rule. Limit of x as it approaches limit of 7. Okay, limit of 7 as x approaches 4. So what's going to be the answer here according to the constant law? Okay, what's going to be answer here? Obviously, our answer will be 7. Okay, because this is a constant and this is a. So therefore, the answer here will be 7. So let's write that down. Okay, let's write that down. So let's start with the second. Second, limit of 15 as x approaches negative 2. It's going to be answered 15. Okay, probably already get the point by now. Okay, so we can just copy everything, as long as you have a function, as long as you have a constant. Okay, just going to copy everything. Just going to copy everything, regardless of what a is. Going to copy everything, provided that it is a constant. Okay, so you can't be guessing either. You have to know that it's a constant. So 6. Oh, it's actually 25 there. And this is actually pi, and this is actually negative 9. Yeah, kind of misplaced that. Okay. So we kind of misplaced that. And negative 9. And we got 2 over 3. We got 8. What is the limit of negative 12 as x approaches 1? Obviously going to be negative 12. Okay. So 1000. 7 over 8. You probably get the point already. So let's check the answer sheet. Let's see if it's correct. Let's see if our answers are correct for constant rule. Okay. So everything is correct. You just have to copy and paste in the constant law. Okay. So let's go to the next law. Since the constant law is kind of easy, you can't deny that. So let's go to the identity rule. Okay. Identity rule says here identity law. Okay. The limit of x as x approaches a is equal to a. Okay. So let's immediately get a problem here. Let's immediately get a problem. We have limit as x approaches 5. Okay. X limit of x as x approaches 5. It's going to be 5. Correct. Okay. And that's going to be it. You just have to copy whatever a is. Okay. If the limit is x, try to find a limit of x. The answer is going to be a. Whatever number x is approaching on. Okay. So that is it. For the identity rule, you can just look at the answer sheet right here. As long as the variable is there is a variable, okay. As long as there is a variable like x, y, z, whatever, okay. It's going to be be A. The answer is going to be A. Let's check. Okay, so we're correct. 5, negative 7. That's correct. Just copy everything. Okay, so now we get to the good stuff, constant multiple law. So what is the constant multiple law? Okay, just have to, no. Let's go to sum rule, Actually go into the sum rule first. Sum law, okay? So sum law. We have here sum law. It says here, limit of x as it approaches a. Okay, limit of function x times g of x. Let me just times g of x just okay, times g of x is equal to L plus M, I believe. L plus M. Okay. So that's going to be the sum law. Let's use it directly. Okay. So suppose we have the sum rule over here. So we have limit, okay, of as x approaches 2 and x plus 5. So what we're going to do here, okay, what we're going to do in order to get the answer, okay, so we're just going to add, okay, so we're just going to add both of the functions here. So since there is two functions here, x and 5, we're going to separate both of them, and we're going to have x and then plus the limit of 5 as x approaches 2, and our answer is going to be, okay, what is x? X is a variable, okay, so automatically you replace it with a, and a here is 2, so then we have 2, okay, we have 2 over here, and then since we have a constant here, okay, then we're just going to use the constant rule, 2 plus 5, it's going to be 7. So our answer for 1 is 7. Let's see if it's right. Let's see if it's correct. Let's go to the sum rule 7. Correct. Okay. So it's going to be about it for the sum rule. But we're going to finish all of this. I'm going to finish all of it. Okay. So it's gonna save us some time, but we can just get the problems. Problemos. Okay. So you can just copy and paste that. Okay, screenshots, and then we got problemos. We got here problems. Hold on. Okay, so we got problems here. Now, okay, since this problem has 3x, okay, and this is part of the constant multiple rule, I'm just going to explain the constant multiple rule first, and then we can jump straight to the sum rule, okay? So we have constant multiple law. It's basically just this. So whatever this is, okay, you just have to sort of multiply whatever number, okay? So you have 3x. Okay, the constant multiple rule basically goes like this. Suppose you have a limit, okay? Let's just use the second problem here. We have limit of 3x plus 8 as x approaches 4, okay? So since we have a variable and a constant, okay, no, we have a monomial here, 3x. What we're going to do with the x, okay, we're going to substitute the x for whatever the a is. So you're going to have 3 and 4. 3 times 4 is going to be 12. That is the constant multiple rule in a nutshell. Okay, now that we discussed the constant multiple rule, we can just be free to do this. So this is a constant, plus the positive 8 is a constant. So you just have to copy 12 plus 8, 20. So our answer for our sum rule problem here is going to be 20. So let's just do that. Let's just keep grinding these problems. 2 times 1, that's going to be 2 plus 7, okay? 2 plus 7 is going to be 9. 4, okay, so 4. X, okay? So now we have what we call the, I believe it's the power law, okay? So whatever the power law is basically just this, okay? So you suppose we have a limit of this, limit of x squared, okay? Limit of x squared. Whatever a is, okay, that's going to equal x. You just have to substitute x with a. Then once you do that, you just copy the, okay, you just copy squared, or whatever the exponent is. So suppose you have this, okay, so x squared. Then you have x, suppose is 5. A is 5. So you have x squared. So what's going to be the answer? 5 squared. It's going to be 5 squared. Okay, so 5 squared is 25. 25 plus 6. 6 is a constant, so we just leave it be. 25 plus 6, it's going to be 31. So that's going to be the answer for 5. So let's just do this, okay. Variable, again. So we have negative 2. Negative 2 plus 12, it's going to be positive 10. Okay, so 6. So now we have the constant multiple rule and the power rule, okay? I'm sorry if I'm getting rule and law mixed up. I think they're just about the same. It's just a matter of phrasing, okay? You can call it whatever you want, I believe. So we have, okay, we're in number 6 now. So we have x, okay, so negative, that's going to be negative, oh, I think I skipped a number. Let me just, yeah, I skipped the number. So we have 5. This is actually the answer for 6 here. It's actually the answer for 6. So we have 5. 4, so there's a constant multiple, okay? So now we have a constant multiple. Okay, so we have fourth number. That's actually wrong here. We had fourth number first. Alright. Let's do the fourth number. So, considering that there is an x here, variable, power rule, okay? So we have to just get 5, and then 5 here. 5 times 5 is going to be 25 plus 6. Then it's going to be 31. And 5, number 5 here is going to be, okay, so we just have to multiply the variable on x. 4 times 3, it's going to be 12 plus 9, it's going to be 21, okay? See? So, 6, we've already answered 6, and then just go to 7. Let's go to 7. Limit of 2x squared plus 1 as x approaches 7 is going to be, okay, so we just have to put the 7, a, into x. So it's going to be 7 squared. 7 squared is basically 49, and 49 times 2, okay? 49 times 2 is going to be 96. Okay? 96. We have 96. 96 plus 1 is going to be 97. I think 7 questions will be enough. So let's check if our answers will be correct. Okay, never mind. I'll just finish everything. I don't want to be lazy, bro. I'll just do I'll just do everything. So 6 here is going to be 6. Okay. So what is 6? Okay, 6. 6 plus 15, it's going to be 31. Okay, so 9, okay, so 5 times 10 is going to be 50. Plus 4, okay, 5 times 10, 50, plus 4, 54. Let me just... So, limit of 3x squared plus 2 as x approaches negative 4. So, same procedure, we're just going to have negative 4, okay, so negative 4 times negative 4 is going to be positive 16. Positive 16 times 3, okay, positive 16 times 3, I'm going to have, okay, 48. We're going to have 48 plus 2, it's going to be 50. So let's check our answers for if they're correct. And the sum rule, okay, so we have, 27, 7, 29, 31, 21, 10, 99. Oh god, I actually did a quite a bad arithmetic mistake there, but 7 is going to be 99. It's actually going to be 99. I must have did something wrong in the arithmetics, but the concept is pretty much correct as the way I explained it. So let's go to the next law. All right, so let's move on to the next rule. What's the next rule going to be? It's going to be about a difference rule. Okay, so we have the difference rule right here. Okay, difference rule is limit of f of x minus g of x as x approaches a. So we're just going to minus two functions. So let's go to the problems here. We have the difference rule. So x minus 2. Limit of x. What is the limit of x minus 2? Okay. As let me just copy the problems. Just copy the problems right here. Problems 2. So we don't have to do everything over and over. So we have here a limit of x minus 2. Limit of x minus 2 as x approaches 3. So we're just going to minus both of those. Difference rule basically just minus subtracting both of the functions. So we have two functions, x and negative 2. So let's just copy and paste that. Limit of x minus 2 as x approaches 3 is going to be, okay, so we're just going to rewrite that as limit of x, okay, limit of x as x approaches 3 minus limit of negative 2 as x approaches 3. This is a constant and this is a variable, so what do we do? Okay, just do that. Okay, that's going to be the answer. Negative 1, positive 1 is the answer for 1. So we're just going to write the answer here. So let's get to the next. It's the next problem right here. Okay, so limit of x, limit of 5x, limit of 5x, minus 6 as x approaches 4. Okay, so 4 here, 4, 5 times 4, 20, minus 6, it's going to be 14. Okay. It's going to be 14. So we're just going to add 14 over here. All right. So let's go to the next question. So this is the difference law, difference theorem, difference rule or law, whatever you want to call it. Okay, you don't need to get all semantic. So we have a variable here, 1 squared, it's going to be 1, so 1 minus 3, it's going to be negative 2. So negative 2. You can just about do this mentally, you know. So we have 8 here, okay, 8 and then negative x. So 8 minus 2 is going to be 6. 4 times 5, 20 minus 10 is going to be 10. Negative 1 squared, okay, negative 1 squared times negative 1 squared is going to be 1. 1 minus 7 is going to be negative 6. Okay, I mean positive 1. That's going to be positive. Negative 1 squared is going to be positive 1. So we have 1 minus 7 is going to be negative 6. So we have 2 times 6 over here is going to be, okay, it's going to be 12. 12 minus 5, okay, it's going to be 7, I believe. Okay, 12 minus 5 is going to be 7. Okay, so we have 7 here. So 3x, okay. What is 8 squared? 64. So what is 64 times 3? Okay, 64 times 3 is going to be 192. So we have 192 here. 192 minus 1 is 191. 7 times 10 is going to be 70. Minus 9 is going to be 61. So we have x here, negative 3. Okay, negative 3 minus 15 is going to be negative 18. So let's check our answers. Let's check our answers right here to see if we're correct, you know. So we're going to check the difference rule. Okay, so 1, 14, negative 2, 6, 10, negative 6, 7, 191, 61, and negative 18. We're correct. Okay, we could be correct. Now let's go to constant multiple rule. I've already explained this over here. Okay, but of course we're going to solve some problems. Otherwise, how is it going to get in your head? How are you going to understand it really? How are you going to comprehend if you don't try it, if you don't solve any problems with it? You know, that's just the thing that I learned about math. You can never learn it if you don't try it. So let's get the problems set up. It's going to be theorem. Okay, so constant multiple rule, I've already explained it earlier, but we're just going to show you how it works with problems. So we have here 4 times 8. 4 times 2 is going to be 8. 3 squared, 9. 9 times 7 is going to be 72. Wait. 63. Sorry about that. All right, so 9 times 5 it's going to be 45. Okay, so we have the 45 over here. So negative 2 times negative 2. Okay, we have positive 4. Positive 4 times 6. It's going to be 24. So we have 12 times 4. You basically just have 12 times 4 over here. Okay, so it's going to be 40. Okay, 48. So we have 15x squared. 15x squared. So we have 1 squared. It's going to be just 15. Okay, so 8 cubed. Okay, so 8 times 8. 8 times 8 is 64 times 8. It's just going to be, okay, so we have 8 times 64 times 8. So we will have 512. So 512 times 2, that's going to be 1024. Okay. So 11 times negative 5 is going to be negative 55. Okay, negative 55. Okay, so we have 10 times 20 is going to be 200. Then we have x squared. X squared is going to be 6. 6 times 6, 36. Times 5, it's just going to be, okay, 180. So let's go and just check out if we're correct on constant multiple rule. Okay, so we have 863, 45, 24, 48, 15, 1024, negative 55, 200, 180. That's correct. Now let's do the power. Let's do the product rule. We still have a lot more rules to do. This is very simple. It's very simple. What trips me, what trips me in these kinds of things is just the algebra of it. I don't uh, I don't really find the concepts difficult to understand. In fact, I get them pretty easily. I get the concepts pretty easily, but sometimes I kind of overlook some simple arithmetics, and then the whole problem just gets messed up. So it's going to be a product rule. So what we're going to do is we're just going to times both of these. We're just going to times both of them. So just substitute the variables. 2 plus 3, 2 plus 1. It's going to be 3 times 2. Okay, 6. Okay, so 3 minus 1 is going to be 2. 3 times 2, 6. 6 times 2, okay, 6 times 2 is going to be 12. So we have over here 4 plus 2, it's going to be 6. 4 minus 5, it's going to be negative 1. So 6 times negative 1 is negative 6. So we have 1 over here, 1 squared is going to be 1. 1 times 1 plus 3 is going to be 4. 4 times 1 is going to be 4. So we're going to have 5 times 3. Okay, so it's going to be 15. 5 times 2 is going to be 10. So 15 times 10 is going to be 150. Okay, so next. Negative 2 minus 1. Okay, negative 2 minus 1 is going to be negative 3. Then we have negative 2 over here, plus 4 is going to be 2. Negative 2 times positive 2 is going to be negative 4. 6 squared, okay, 6 squared, going to be 36. It's 36 times 6, okay, 36 times 6. We're going to have 200, I believe, 260, 280. Yeah, let me just use the calculator. 36 times 6. Yeah, it's going to be 216. I was off by 2 numbers. Okay, so 216. So now we have 2 times 7, 14 plus 1. It's going to be, okay, 2 times 7, 14 plus 1, 15. Then we're going to times it by 7. Okay, so now we have 7 and 105. So now we have 8 minus 3. It's going to be 5. Okay, 8 minus 3. It's going to be 5. And then 8 plus 3. It's going to be 11. 11 times 5, 55. So now we have 10. 10 squared, 100. And 10 squared, 100 as well. 100 times 100 is going to be, I believe, 10,000. So let's check our answers. Let's check if we're correct. It's going to be product rule. So we have, okay, so we 6, 12, correct. Negative 6, correct. 4, correct. 150, correct. Negative, hold on. Negative 6. I must have did something wrong. Oh, negative 3 and then negative 2 plus 2. Oh my god, that's actually negative 6. I was wrong in that. No, that's actually negative 6. You see what I'm talking about? I actually make a little bit of arithmetic mistakes from time to time, but so forgive me for that. We got 216 correct, 105 correct, 55 correct, 10,000 correct. We got the product rule. Okay, so now we're done with the product rule. Let's go on to the next rule. I'm gonna be quotient rule. So the quotient rule is basically just you dividing stuff. It's gonna be you dividing stuff. Okay. So let's do the quotient rule. Then we're gonna do evaluations as well. So quotient rule first. Let's get the problems over here. Simply get the problems, and we got the problems here. So we have the problems here. You basically just divide, you know. So same thing. Variables, identity law, identity rule. Okay, so you get 2 plus 1. 2 plus 1 is 3 divided by 2 is 3, 2. 1 is 3, 2. Let me just write that out. Let's just write that out here. So we have 3 over 2. Now we have 2 times 4, it's 8. Then 4 plus 2 is 6, so 8 over 6. So limit of x squared is going to be 5 squared. 25 divided by 2 is going to be 25 divided by 2. It's going to be 25 divided by 2. Then we have limit of 5 times 3 is going to be 15. 3 minus 1 is going to be 2. So 15 over 2. 6 plus 4 is going to be 10. 6 times 2 is going to be 12. Okay. So we have 10 over 12. So now we have 1 plus 1. Okay. 2 over 3. It's going to be 6 over 4. It's going to be 15 over 3. Or 15 over 5. So we have 7 over here. 7 here. So you have 3 times 7. It's going to be 21 divided by 2. Okay. 21 over 2. 9 squared. Okay. 9 squared. It's 81. 9 plus 1 is 10. So you have 81 over 10. Let's check the answers. Let's check if we're correct on the quotient rule. Quotient rule. And we would be correct. You actually can divide it. You can actually simplify this by 2 as well, because 8 divided by 2 is going to be 4. Yeah, you can simplify this. I just forgot to simplify. I thought it was going to be the... Yeah, so we're correct. We will be correct. And this will be simplifiable 2. So 2. So we have 5 over 6. We have 5 over 6 and 5 over 6 and 2, 3. 6, 2, 3. Check. You can actually do 3 over 2 here. Okay, so you always make sure to simplify your answers. 3, 21 over 2, and then 81 over 10. That will be correct. Everything is correct. So now let's do power rule. We're almost done with all the limit theorems. Okay, so now we have the power rule. Okay, so we're just going to get the power of everything. Yes, just basically just it. We basically just ran this over already. So there's not much to discuss here. Let's get the power rule. Power rule over here. And this will be here. Okay. So now we have this. 2 cubed. It's going to be 8. 5 to the 4th power. Okay, so 5 times 5. Let's do 5 times 5. Okay, it's going to be 125. 125 times 5. Okay. That's going to be 625, I believe. I believe that is. Yeah, 625. That'll be 625, and then we have a cube over here. 3. 2 times 3. No. 3 times 2. It's gonna be 6. 6 cubed, 36. 625. Then we have 4 minus 1. Okay, 4 minus 1. It's gonna be 3. So 3 cubed, 3 times 3, 9 times 3, it's going to be 27. So now we have this. 6 plus 2, it's going to be 8. 8 times 8, okay, 8 cubed, it's just going to be 64. So now we have this, negative 2. Oh, crap, it's gonna be actually really bad. Yeah, negative 2 to the fifth power. So negative 2 times negative 2 is gonna be positive 4. Positive 4 times negative 2. Positive 4 times negative 2 is gonna be negative 8. Okay? So negative 8 times negative 2 is going to be positive 16. And then positive 16 times negative 2 is going to be negative 32. So our answer will be negative 32. So now we have this 30 times 30. Okay, 30 times 30 is going to be 900. So now we have this 1 squared, 1 is going to be 1 still. So now we have 7 minus 3, 4, 4 to the 4th power, 4 times 4, 16 times 4, it's going to be 64. Okay, 64 times 4. And that's going to be, okay, it's simply going to be 256. Then 9 plus 1. I'm just going to use the calculator for this because it's actually a big number. 9 plus 1 is going to be 9 plus 1 can, oh no, I don't actually. Oh, I'm just going to use a calculator then. It's going to be 100,000. 100,000. So that's going to be power rule. Power rule. So let's see if our answers are correct right here. So we have the power rule. 8, 6, 25, 36, 27, 64, negative 32, 900, 1, 256, and 100,000. We are correct on everything. Now let's do the root rule before we immediately, okay, do the evaluation. Okay, we're going to evaluate some limits through factoring, and this is what they do in calculus actually. Probably the most advanced type of limit that I know of is evaluation through factoring. So now let's just do the root rule or the root theorem or the root law, whatever you want to call it. Okay, so now let's do the problems right here. Let's do the problems. I'm gonna go. Hold on. Okay, so now we have the root rule. And what it says here, you basically just put the limit inside the radical symbol. Then you just do the roots as usual. The square root of stuff, you know. So what is 4? Square root of 4 is going to be 2. Square root of 9 going to be 3. Cube root of x, okay? So cube root, how many times do you multiply? You have to multiply 3 times in order to get 8, okay? So how do you do that? So you basically have no, that was actually a wrong sort of definition of it, but I know the answer is going to be 2. The answer is going to be 2. We have 16. What is the cube root of 16? Square root of 16 is going to be 4. Square root of 25 is going to be 5. Cube root of 27, I don't really know. Let me just I haven't really memorized the cube roots. Okay, so 3, this we actually have 3 here. Okay. God, I know the cube roots. So this is going to be 6. Cube roots 36, 64. It's going to be 4. It's going to be 4. Then it's going to be 7. It's going to be 125. 125 is 5. So it's going to be the root rule, the square root rule. Okay, so 2, 3, 2, 4, 5, 3, 6, 4, 7, 5. Okay, so we're correct. We're correct in the root rule. Now let's go on to the good parts. Okay, factoring. Let me just look at my notes here. All right, so we have a bit of a problem here. Okay, so let's do it. We have to evaluate these equations. Okay, so we have x squared minus 4, x minus 2. We're trying to find something that basically multiplies and adds multiplies to negative 4. What are the two numbers that multiplies to negative 4? And it's going to be it's going to be positive 2 x plus positive 2. We're going to factor that. If we're going to factor that, we got x minus 2, x plus 2, and x minus 2. So we have x minus 2 at the bottom. We're going to cancel these common factors. No, that's not called a common factor. We're just going to cancel the common terms, the like terms. And then we'll have x plus 2. Okay? We'll be left with x plus 2. So you substitute that with the a from the limit. So 2 plus 2 is equal to 4. That's going to be the answer. Okay? The limit of x squared minus 4 over x minus 2 as x approaches 2 is going to be 4. Okay. Let's check the answer sheet. So we're going to so we can guarantee that we're going to the right fat. Oh my God, I'm correct. That's correct. Okay, that's my first time doing that. Okay, so that's gonna be 4. Let's just go through the motions of everything. Just go through the motions of everything. So you have x squared minus 9. We have to factor that. So you have x plus 3, x minus 1, x minus 3. We have x minus 3 here. Cancel. You have 3 plus 3. It's going to be 6. It's very simple. So now we have x plus 5. Just have to factor everything, x plus 20, x minus 5, and then x minus 5. We have x plus 5. 5 plus 5 is going to be 10. It's easy. It's very easy. And I believe we also have what we call polynomial functions. We're going to do 10 problems of that, and then that's going to be it for every single theorem for limits in calculus. We're just going to solve this. Okay, so x squared is going to be the x plus 1 times x times negative 1, x minus 1, then x minus 1 here, x minus 1, 1 plus 1 is going to be 2. Or you could just completely skip everything, okay, when you have binomials. It's very, very easy. It's very easy. So you have x squared minus 16 So what multiplies to negative 16? We have x plus 4 times x negative 4, the x minus 4 here. 4 plus 4 is going to be 8. So now we head over to the polynomial functions. Okay, polynomial. This is actually a polynomial limit wherein we evaluate it through factoring. But there is also another form of polynomial functions in limits that we can just sort of do the rules, apply all the rules that we mentioned earlier. So we have this, okay, x squared. What? Since we have x minus 6, okay, I believe there has to be by the way, if you get 0, okay, if you get 0 over 0 when you're solving for limitations, no, I'm sorry. If you get 0 over 0 when you're solving for limits, that's when you evaluate. Otherwise, that's when you evaluate through factoring. Otherwise, if the substitution goes well, there's nothing else for you to do. Okay, so let's try it here. I forgot to do that on these because I know I'm gonna need to factor everything here. But let's try it. Let's just evaluate everything. Yeah, 2 squared plus 2 minus 6. 2 squared is 4 plus 4 plus 2 is 6. 6 minus 6, okay, 0. 0 over 0. It's going to be 2 minus 2 is going to be 0 over 0. So we're gonna have to factor that. So what factors 2? Negative 6. Okay, so we have positive 3, x plus 3 times x minus 2, x negative 2. Then we're going to have x negative 2 here. Then we're going to have 2 plus 3 is going to be 5. Very simple, very simple. So we now have this limit, okay? We now have this limit. So let's try to evaluate it first. So we have 3 squared minus 5 times 3 plus 6, then 3 minus 3 is going to be 0 over here. 3 squared is 6 minus 15. 6 minus 15 is going to be 6. It's going to be 6, I believe. It's going to be 6. 6. No, 3 times 3 is going to be 9 minus 15. It says 15, right? 9 minus 15 is going to make about 9 minus 15 is going to make just 6. Okay, so we have 6. 9 minus 15, negative 6 plus 6, we're going to have 0. So now we have to factor that. But how do we factor this? That's the question. Okay? So we just have to get two numbers. That corresponds with 5, negative 5, and plus 6. So what multiplies positive 6 and adds up to negative 5? So we can have negative 3 and negative 2. So we have negative 3, negative x minus 3, and negative x minus 2. Then we're just going to have x minus 3 over here. Cancel that. X minus 3, 3 plus 2. 3 plus 2 is going to be 5. Okay? So let's check the let's finish all these first. Then we can do we can check out the answer sheets. Check out the answer sheet. Yeah, I believe we can do that. Uh-huh. So we have this x squared minus 3x plus 2. Let's substitute 1 squared, 1 squared. Okay, let's just do it mentally. 1 squared is 1 minus 3. 1 minus 3. No. 1 in the 3 here. 3 times 1 and plus 2. And 1 minus 3. 1 minus 3 is going to be negative 2. Negative 2 plus 2 is going to be 0. Then we have 1 minus 1, 0. So you have to find out what adds up to negative 3 and multiplies to positive 2. Okay? So then we have negative 2, okay, and negative 1. So x1, x2, cancel that, cancel negative 1, x minus 1. 1 plus 1 minus 2. Okay. 1 minus 2. It's going to be negative 1. Negative 1. Okay. So we have negative 1. And for this, we have to do this. Okay. So we just have to factor everything here. Of course, I'm going to have to factor this. We can just evaluate it. 5x, okay, 5x. What adds up to 5 and multiplies to? What adds up to 5 and multiplies to 6? So we have positive 3 and positive 2. Okay, so x plus 3 and x plus 2. We have x plus 3 and negative 2. Negative 2 plus 3 is going to be 1. Okay, so now we have this. What adds up to negative 7 and multiplies to positive 12? So obviously we're going to have let me just it's gonna be 0. No, that's gonna be 0. So what multiplies to positive 12 and adds up to negative 7? So we're gonna have both negatives. We're gonna have we're just gonna have negative 4 and negative 3. So x negative 4, x negative 3. We just have to cancel x negative 4, and then we have x negative 3. So 4 plus 3. No, x minus 4 minus 3 is just 1. So that's gonna be our answer for factoring. 4, 6, 10, 2, 8, 5, 1, negative 1 and negative 1, 1 and negative 1, 1, 1, 1. So that's basically it, that's it for all of the theorems of limits in calculus. But we also forgot about the polynomial functions. Okay, so let's do just that. Okay, so I think I'm just gonna have like you know what? I'll do all of it. I'm going to do all of it. So we're just gonna get this. It's we're going to copy and paste the screenshot right here, right here. Okay. So just substitute. We just substitute. So 2 squared, 4 times 3, 12. 5 times 2, 10. 10, 12 minus 10. No. 12 minus 10 plus 1. 12 minus 10 plus 1. It's gonna be 3. 3 points. Okay, so we have 3 over here. So we're correct. -1. It's gonna be negative in the third, so 2 times -1 is gonna be -2 plus -1 and +1. -2 plus 1, -1, and -5 is gonna be -5. So now we have this. Okay. 4 cubed, I believe, is something along the lines of 64. Yeah, 4 cubed, 64. Minus 2, 4 cubed of 4 squared. 4 squared, 16 times 2 is 32, and then 64 minus 32, that's going to be 32 plus 5. 32 plus 5 times 4, 5 plus 4, 20. That's going to be 32 minus 20. Okay, 32 minus 20 is going to be 12 minus 7. We're going to have 5. 5 here. 5 squared, it's going to be 25. 25 plus 4 is going to be 100. 100 minus 9 is going to be 91. So now we have 3 to the power of 4. What the hell is that? 3 to the power of 4 is 81. Okay, so 81. You have 81 here. 3 to the power... Oh, it's actually a -3. Well, either way, I think that's just about enough. You guys probably get the point of polynomial functions. Basically just everything combined. Every single rule in theorems of the limits of calculus, basically just that. It's basically just a lot of variables in one question. So that's about it, you guys. So that's going to be it.